Hello there, this is Steven. Recently, I built this openconnect wrapper, which basically just runs openconnect, but it fills in the user and password, etc. And it gives me an ability to press R and enter to reconnect. Basically, it just queues openconnect and then does all the things again. Okay, so why do I need this? I constantly have my computer connected to VPN using openconnect because of this. See? Now let's do a live demo. I have already compiled the client and it's going to fill in the group, fill in the username and password, but I still need to manually type in the response because this is multi-factor authentication. I need to use a phone to open an app, which gives me this. Okay, so it should be connected. And as we can see now, I can open Google, right? The thing is, after a while, I could get very bad connection. And I would need to try to openconnect and reconnect. So usually I would do this, and then I would need to type in the group and username and the password and then the thing. And if it doesn't have connection again, I will need to do it again. So when you do it 20 times a day, it becomes very annoying. But with this, if it doesn't go through, and it will connect to openconnect. Okay, so if I open Google now, it works. But if I want to reconnect, which is just like manually hitting ctrlc in openconnect and doing everything again, I just press R and enter, and it will close it and do this again. One of the more amazing thing is, as I am doing this, I can simultaneously input the response and it would go in the proper order. Enough talking. Let's look at the code. This is a binary project in Rust, and you can see it's 70 lines with documentation. So I want to show the initial version of this project first. I was trying out the command in Rust standard library. The way you do it is you spawn a new command which calls openconnect, and then it throws it an argument. In this case, this is the URL for Duke VPN, and it calls spawn. And if you check the documentation, it uses output, but it also supports spawn. So the difference between output and spawn is that output waits until the process finish and collects its output, standard out and standard err. But spawn just spawns it and let it run. And standard in, standard out, and standard error are inherited from the parent, which means you can just access the process like you would do as if you are spawning it using a shell command. In this way, this little program would essentially do exactly the same thing as openconnect does. Okay, let's move on. So in the second version, first thing, I changed the result because all the results are of IO result type, so I ditched the dime books and I tried to implement this refresh thing and the stdin thing. So the way you get stuff from stdin is actually initialize this stdin variable, and then you do stuff to it. So you can, in here, I do stdin read line, and it will wait until an enter is being pressed and read the new line into the string buffer. So I compare the string buffer to R and new line character, which I initially forgot and found it wasn't working. If this happens, I know I need to reload the whole thing. So I kills the process, which forces the child process to exit. And this would cause problems later on. There are no other methods that access the child process, which command spawn provides. And I assign a new process to the variable process in main function and get the process's stdin. So this is when I spawn the process, I gives it a piped stdin, and later I can use this helper function to take its stdin and return this stdin. Because we have its stdin, we can use the write all method to write the group username and password into this process. That's why we don't need to type in these information in openconnect manually. If the buffer is an R, which it could be, because we need to pass in the response, which is a number, to openconnect to do the MFA. So I would detect whether it is a buffer with only numbers. This detects whether the buffer is consist of numbers. If it is, it would go into the stdin of the process we spawned. Otherwise, we just print an error. Now the problem with this version is that it does work the first time I connect, but when I hit R and then return, openconnect hangs. Approximately, openconnect hangs here. And after a long while, it says authentication failed. Therefore, I went to investigate and found that when using in the terminal directly, openconnect has a shutdown phase. So if we do it here now, we will see it would send a buy packet and delete the gateway. But when I was using the program that I built, because I just called process.q, openconnect got SIGQ, so it just immediately exited. And the only way I could connect to openconnect again was rebooting my computer, which is really sad. I went to investigate this, and the conclusion came that I need to send a SIGTERM to openconnect instead of a SIGQ. The child struct only provides a SIGQ, which in some of the discussions I searched is explained as Windows doesn't have the different signals that Unix have. So I have to use something else. In this discussion, somebody asked how to send a signal to a child subprocess, and the answer was pretty good. So there's this Nix library that can send a signal of your choice to a child. But notice here, it's sending this to a child.id, which returns the OS assigned process of this child. If you think about it, where do you see it? When you queue a process in Unix, you type in Q and the ID of the process. It would send a SIGTERM by default. So that's what I did, because I didn't want to add another dependency to my binary. I restructured the code at the same time because I realized overriding process and process stdin is not a very good way. So I put them in a loop. The outer loop creates openconnect processes, and the inner loop reads new lines from the program stdin. Because of the way Rust works, when the program reaches the end of a loop, everything inside the loop goes out of scope and gets cleaned up. Therefore, in this outer loop, I just need to redeclare the process variable and the process stdin. I made this QProcess function so I can pass in essentially a string, and it will spawn a command Q to queue the string, which should be an ID, and would wait for the queue to be done. Initially, I used this QProcess function manually when I reload the program. But later I realized when the program gets ctrlc, this won't run. And the way a Rust program exits is that it cleans up everything inside of it. So process got killed, and the way it's cleaned up, it's obviously again by sending a SIGQ. So the VPN would not work again until the next reboot. My first intuitive was to use this create ctrlc, which catches ctrlc and calls a function like this. The problem is the process I need to queue has an ID, and the ID is a variable, not a constant. And this function does not accept arguments. And this function can only be set once because it's a whole thread running in the background. I attempted to solve it using a constant and unsafe blocks inside of this function, so it can access the variable. However, I felt maybe I didn't do it quite right, and every loop when I spawn a new ID, I would need to use an unsafe block to update that ID. Unfortunately, that code is gone now. I deleted all of them without a commit. I found the code very hacky and potentially not reliable. Obviously, if I do that, I'm making the IP a shared variable between two threads, and it should obviously have a mutex and an arc. But I don't like the idea. Eventually, I remembered that Rust supports RAII, resource acquisition as initialization. And when the resource is cleaned up, it can run a destructor. In C++, that's what it's called. In Rust, it's called a drop function. So I can just queue the process when it is dropped properly using the queue command. In this way, I can get rid of the queue function here and just make my main function much cleaner. So there we go. We have a fully functional program that runs another process and pass in things in its standard in every time it initializes, which also supports reloading the inner program and passing in things to the program standard in. I might as well just did this in Python, but it didn't feel interesting to me because first, Python just does not have very nice documentations. Look at this. But more importantly, I already have enough bloat on my computer running. I have Better Touch Tool, Yabai, Amethyst, and Alfred constantly running. And I have openconnect, which is another bloatware. I use VS Code, which is a resource hog, so I might as well save a Python runtime. We can clearly see that these processes cause very little resource usage. Oh my god, what's wrong with btop? Okay, let's just use good old activity monitor. Okay, now we have real stats. They're using nearly no CPU, and the memory footprint is very small. So there you have it, a Rust wrapper to run another program. I hope you like it, and maybe you can suggest some improvements.